You all know mobile networks, you all use mobile networks, and you know that in some parts of maybe the city or the country, there's a good connection. In some parts, there's the connection not that good. The reason is that the network quality is not exactly the same in all parts of the country. The reason for the problem is that the propagation of the electromagnetic waves is not deterministic in all areas, and that's why the network operators do, so to say, drive tests to analyze the network quality. And the result of a drive test might be that in some areas of the city or in some areas of their region of operation, they have a low quality, and they would then place new base stations there to support a stronger network quality. The problem with this drive test is that it might be a lot of effort because the companies have to organize the drive tests. The companies have to actually do the drive tests, setting a driver into a car equipped with equipment for measuring, and it costs a lot of money. So the idea is to save the drive tests and to even get better data about the network quality. The idea is to use the users' phones for measuring the network quality anonymously and for communicating these measured quality values to the network operator. And with these data, the network operator can see where there are areas of low coverage, of lower network quality, and the network operator can then improve the network by placing a new base station into this area. So what we have again here are these building blocks for a big data application: data acquisition, storage, analysis, visualization. And we apply that here to our situation for the mobile network analysis. So first, the data acquisition in this case is done by the user's phones without his knowledge. In many cases, the user gets a certain small, very small software which regularly measures the network quality. It's a software which you do not see at all in your Android or iPhone, and it works in the background. In the background, it also communicates these measured values to a centralized data storage, to a centralized database where these data are saved for further evaluation. And if you imagine that many phones of your customers are equipped with this software, and many phones regularly measure the network quality, then you can conclude that there's a huge amount of data which is acquired by all the phones together. Then comes the data analysis, and the data analysis has to go to determine in which network areas is the quality so low that the network operator has to improve the quality by placing new base stations, for example. So identifying critical network quality areas is the key goal for data analysis. And therefore, again, the geographical segmentation has to be done. The qualities of the different measurements from the different users have to be merged together, have to be aggregated. And finally, the data are available for a visualization such that the network engineer can evaluate the data. The visualization then can look like here on the right side. On the right side, you see such a surface plot or a heat map maybe also, which is a little bit different. Where you can see in some areas there's a good network quality. Let's say the higher areas are the areas of higher network quality, and the lower areas are areas of lower network quality. And maybe here you can see on this street, if you are on the street, then you have better network quality. If you go into the building, that means you go to such a block, then the network quality decreases because the electromagnetic waves are not able to easily go into the building. And if the network quality is too low, then the network engineer might decide to place a new base station there, or also make some power regulations in the already available base stations. The overall goal for the network operator, of course, is to maintain a stable mobile network without paying too much for too much useless base stations, but only placing new base stations or increasing the power supply in the base stations where it is required, where it makes sense. So optimizing the network operation is the goal of this big data application here. And in the small picture on the upper right side, you can see the schema of the application. Many phones are sending their measurements to a centralized storage, and a network engineer, or many network engineers in most cases, evaluate these measurements to conclude some engineering activities.